All right, it is a chilly morning here in the paradise of Adams County, Ohio, in December of 2025. In fact, I just checked the National Weather Service, and Cincinnati tied a record low of 0 yesterday. But it has been colder than that this early in the season. I noticed that the coldest it's been this early is -13. So we came up well short of that, thank goodness. And in general, we're getting a lot less cold weather than we did decades ago. But we're not here to talk about extreme cold today. Instead, the focus is on the other end of the spectrum. And in the last 13 years, we haven't had much extreme heat either. And it was a much different story in 2011 and 2012. And we're going to get into that. But as far as this lack of extreme heat in the Midwest and the South, it's a little more pronounced in the Midwest. This is recognized in the climate community. There have been papers written on it, and they generally attribute the lack of extreme heat to things like increased rainfall. Some people blame it on corn sweat, which I think is kind of crazy, but or the decadal Pacific Oscillation playing into it, and random fluctuation. Now, personally, I attribute it to there is some random fluctuation. We have been unusual. Not that we've been cool. We've missed out on extreme heat partly by chance, but also a huge factor that is never talked about, and that is aerosol masking. Aerosol masking is the best kept secret in climate science. If you ask the average person on the street what do they think about aerosol masking, they'll have no idea what you're talking about. And if they're my age, they'll think you're talking about hair metal. But the concept is, and it is recognized by the climate nerds, the phenomenon of aerosol masking. But the burning of fossil fuels, and it's mostly coal from the coal-fired power plants, releases aerosols into the air and in the form of sulfates, and they have the effect of reflecting incoming solar radiation. Therefore, it creates a cooling effect. And we know where the coal plants are. They're built, the biggest concentration is here along the Ohio River, and there are a fair number in the South, a few in North Florida, not hardly any in South Florida. There are quite a few in East Texas, and there are a few maybe in eastern Kansas and western Missouri, and kind of sprinkled here and there. So, and the other thing is, the sulfates don't travel that far from their point of origin. They, unlike a volcano that spews it way up into the stratosphere, these stay in the region where they originate from. So bottom line is, west of Topeka and west of Dallas, there aren't hardly any coal plants. So we have a sharp distinction geographically between sulfate levels, is what I'm getting at. The other thing I should say is that there's the biggest effect is when you go from a pristine air to a certain level of sulfates. Once you get beyond a certain level, it seems to have little additional effect. And the other thing is, the effect is biggest when you need it the most. The hotter it is, the bigger the effect. And I know I sound like a paid shill for big coal, but that's just kind of the way it works out, because the sulfates reflect solar radiation. Well, that's the hot days when the sun is high in the sky. That's when you have the most solar radiation to block. There's not much, but if it's a cloudy December day, there isn't much solar radiation to block anyway. So the effect is very minimal. I haven't studied it to a tremendous degree, but from October through February, there really doesn't seem to be much of an effect. And there's not nearly as much of an effect on a really cloudy summer day either. So with that, we're going to dig into the data. Oh, and the other thing I'd say is always ask yourself, does the data fit the narrative? So we'll see. All right, here's one of our tools for figuring out what's happening with the climate, earth.newellschool.net. And it gives you a rendition of the globe. You can zoom in to an area of interest. It actually lets you go back in time about, I think, back to 2017 to pick a certain date to see what was happening. This case, I chose July 24th of this year, one of our warmest days in the Ohio Valley. Chose the sulfate variable because that's what we're interested in. Here, you can see obviously in the east, generally higher values in the east. Here in the Ohio Valley, we enjoy the highest sulfate pollution of anybody in North America. We can't compete with China, but that's a pretty tall order. And what we see, if we look at the how many record highs some of these cities have hit in the last 10 years, Pittsburgh hasn't had any. Peoria, over here somewhere, they had one. Indianapolis had one. Columbus, I think we had 3. The point is, we're not hitting many summer record highs in the Ohio Valley. Now, Albany, I think they had 12. They don't have quite the sulfate levels over there, and some of that disparity is just luck. The Midwest, we've just been really lucky the last 13 years of avoiding the intense heat. Now down south, it's a little more sporadic, a little different climate as well. Charlotte had 6. Memphis had 10. They're hitting similar numbers like that down here. Out here, there's Des Moines. Where's Des Moines? There's this day. This day is not. This is fairly representative, but you got to remember, weather systems change this. Des Moines would usually have probably higher levels. I think they had 3 record highs in the last 10 years. Omaha had 3. Who else? Kansas City didn't have any. And Fort Smith had 7. Dallas, down here somewhere on the borderland. It's I-35 corridor. Seems like I-35 corridor is a dividing line for a lot of things, but Dallas, it's kind of sporadic. Sometimes they have a more westerly wind, and as a result, they have lower sulfate levels. They've had 17 records in the last decade, last 10 summers. Abilene here, with consistently lower sulfate levels, had 43 records in the last 10 summers, 43 versus 17. Corpus Christi, 44. Anyway, that's just one variable to look at. Okay. Columbus, Ohio, home of The Ohio State University. Now, what this is, each bar, 5-year cumulative total of number of days with a high temperature above 94 degrees. It's not as hot as it used to be. As soon as the coal plants got built, and they started, a lot of them were built in the 50s, some more in the 60s. The heat really fell off a cliff. In Columbus, how about Kansas City? The Dust Bowl was a bigger deal out there. And here I'm looking at it, highs over 100. But similar idea. This doesn't look quite as dramatic on this one, but the point is, still in the more recent years, they're not getting as much intense heat as they did many, many decades ago. They did in 1980. They had some heat. 80 and 83, they had a lot of hot days. So it kind of drove this one up. But 2011, 2012, that's a different animal. We're going to get to that really soon. But Dodge City has much lower sulfates. See, what I'm saying is the coal plants were built in the whatever 50s or 60s, killed the heat. Not in Dodge City though, because they have much lower sulfate levels, and it's just gotten hotter and hotter, which is what you would expect, which is what most of the planet is doing. All right, here's the granddaddy. Okay, this is just year by year, not averaging 5 years or anything, but so what I think of this is like a competition among each year to see how much, what are the hottest days you can spit out for every month. So I took the warmest observed temperature for March of 1990. That's a data point. Warmest observed temperature for April of 1990. Do that all the way through the 7 months. And do that for all 9 of these cities. What do we have? Columbus, Albany, Hotlanta, Birmingham, Shreveport, Moline, Omaha, Pittsburgh. That's 9. So 9 times. So there's 63 data points go into each one of these years. Yeah, okay. You got to remember, these guys over here in this competition have the advantage because global warming, a lot of our warming has just happened in the last 10 years. What on earth happened in 2011 and 2012? They just soar above everybody else. And statistically, this is off the charts. If you do this data set is pretty much a standard normal distribution. I would expect it to follow. And the odds of these 2 years, not just 1 year, but the combination of this is, I think 2011 was 2.3 standard deviations above the mean, and this 2012 is coming in at 3.6. The odds of both of these being this high, it was like 1 in 500,000 or something like that. But something had to push it to this level. Yes, part of it was fluctuation to the upside. They were warm years. I know that's true. But what happened? Well, there were mandates to lower sulfates, and they had, by their own government data, sulfate emissions had been dropping pretty steeply in the mid-2000s. I think we hit 2011 and we got below that critical threshold and lost some of our aerosol masking effect. It got hot. I know Dallas had a hellacious heat wave. 2012 was worse. We had that crazy warm March here in the Midwest, and the drought and heat wave in Illinois was kind of the epicenter of that. There are counties out there, they didn't get any corn. So what happened was Obama panicked and they said, no, we need those sulfates back up in the air, because it collapsed right at the heat. The heat just completely vanished right back to where it was. Now again, some of this is the just random fluctuation to the downside, makes it look more dramatic than it was. But these years here, the fingerprints of aerosol masking are all over these years. There's no way we're getting this lack of heat just by chance. Has to be something else. So Obama fought global warming rather successfully by allowing sulfates from coal plants to do their job. He reversed look. I don't know if he did it. Maybe it didn't even make it to his level. I don't know. But he said that. Remember, he in one of his interviews he said, "Oh, those climate reports were terrifying." I'll bet they were, Barack. All right, here's another one. I think this will be the last one. Okay, high sulfate cities, Columbus, Ohio, number of days with 94 plus heat, average, okay, for the last 13 years, 2013 through 25. On average per year, how many days of 94 degree plus heat did we get? 4. Way back 1890 to 1855, we had 8. Pittsburgh 3 versus 7. Evansville. Okay, I use 90. Pittsburgh's not quite as hot, so I use 92 as the cutoff. Evansville is a little hotter, so I use 97. Anyway, point is, high sulfate zone. Last 13 years, we haven't been getting anywhere near the intense heat that we used to get. Now, if you run this for instead of 94 number of days with a high of 88 or more, I did this, and somewhere around there, it's even Steven. The sulfates kill intense heat. It's the weirdest thing. It's so paradoxical. So much of this is just so ironic. Moderate sulfate, well, New Albany almost had as much in the last, not New Albany, Albany, days of 94 plus heat. Kansas City, a lot less extreme heat. Omaha, a little closer. Okay, so yeah, Sioux City, still, again, not getting the heat. Fort Smith did a little better. They had 2023. It was pretty hot in the south. Some of that made it up to Fort Smith. Wichita, Oklahoma City, they're in the borderland with the sulfates. You see, 5 versus 5. It's actually the sulfate level over these cities is pretty low, but just being close to the aerosol masking gives you some cooling. You get out to the low sulfate land, Amarillo, 102 plus temp. Number of I forgot to put this again as days per year. I goofed up down here. Per year, Amarillo in the last 13 years has been averaging 8 days of 102 degrees plus heat. Now this year they really missed out. They got extremely lucky. But the point is, out there they are getting more. Where the sulfates are low, they are beating those earlier years, as you would expect. Anyway, read into it what you want, but this is just what the data, what it spits out.